I would like to discuss some problems that are similar to the ones on Lab 7 and 8. You should have received this document not too long ago in an email, and I also have it posted in the discussion area. But I would like to talk about the details of these problems. So the first few problems are actually from the end of chapter 4. Section 4.9, which is antiderivatives. So on page 356, problem 41, what we're given is the second derivative is sine theta plus cosine theta, and we're given that f of 0 is 3 and f prime of 0 is 4. So we need to find an antiderivative. It's the reverse process of differentiation. So, what do you take the derivative of to get sine? Well, the answer is negative cosine, because the derivative of cosine is negative sine. And what do you differentiate to get cosine? Well, the answer is sine. And you can check your answer by differentiating. Now remember that we always have an arbitrary constant. So these are our initial conditions. So as of this moment, we can now determine C because we know f prime of 0 is 4. So right now, plug in 0 for theta. F prime of 0 is 4. Plug in 0. Well, cosine of 0 is 1, so we have negative 1. Sine of 0 is 0. Negative 1 plus C is 4. Therefore, C is 5. So I know now that C is 5. So therefore, f prime of theta is negative cosine theta plus sine theta plus 5. Now, we're not done yet because we're asked to find f. So we need to, again, find an antiderivative. So what do you differentiate to get negative cosine theta? Well, the answer is negative sine of theta. What do you differentiate to get sine of theta? Well, the answer is negative cosine of theta. And what do you differentiate to get 5? Well, 5 theta, because the derivative of 5 theta is 5. And we also have an arbitrary constant. We're given f of 0 is 3. So if I plug in 0 for theta, I have to get 3, so now I can determine the arbitrary constant d. d is 4. So f of theta is negative sine theta minus cosine theta plus 5 theta plus 4. Problem 43. Also on page 356. So we're given f double prime of x, the second derivative of f with respect to x, is 4 plus 6x plus 24x squared. Now we have initial conditions, but in this case they're both on the function itself. Remember the previous problem we had conditions on both the function and the derivative. And actually initial condition is not the correct term because this is f of 1. So we just have two function values that need to be satisfied at the end. So this is polynomial, it's very easy, okay? So an antiderivative of 4 plus 6x plus 24x squared is 4x plus 3x squared plus 8x cubed plus an arbitrary constant c. So notice what's happening here. We're using the power rule for antiderivatives. It's the opposite things in the opposite order from derivatives. What we do is we add 1 to the exponent and then divide. Okay. Well, we're not done yet. This is f prime. We need f. So repeat that process. So f of x is 2x squared plus x cubed plus 2x to the 4th plus cx plus d. And again, what you can do is differentiate this line and you get back that line. So now plug in 0 for x, we got to get 3. So that determines d. So d is 3. And if I plug in 1 for x, I gotta get 10, right? So I plug in 1 for x now that we know the d is 3. We can determine c. So rewrite this line, but put in the values for c and d. So f of x is 2x squared plus x cubed plus 2x to the 4th plus 2x plus 3. F double prime of x is equal to x to the negative 2. And we're told that x is positive. That's important. F of 1 is 0. F of 2 is 0. Well, the antiderivative of x to the negative 2 is negative x to the negative 1 plus an arbitrary constant. Repeat that process. Antiderivative of negative x to the negative 1 is negative ln x. The antiderivative of c is cx, and of course we have an arbitrary constant d. So this is our function. We took an antiderivative twice, right? And now we're going to plug in our conditions. F of 1 is 0, f of 2 is 0. So if I plug in 1, I determine that c and d are opposites. Ln of 1 is 0. So when I plug in 1, what I end up with is c plus d is equal to 0, so c is the opposite of d. So plug in into your other equation. We'll get everything in terms of c. So when I plug in 2 for x, I get negative ln of 2 plus 2c, and d is the opposite of c, remember? So that's going to be, replace d with minus c. So I get d is negative ln 2. So rewrite this line, but in place of c and d, we have c is ln 2, d is negative ln 2. So f of x is negative ln x plus x ln 2 minus ln 2. Similar problems on page 361. These are from the chapter review, I believe. So we're just asked for an antiderivative, the most general antiderivative. So f of t is 2 sine t minus 3e to the t. So we use a capital F to indicate the antiderivative, just by convention. So what do you differentiate to get 2 sine t? Well, it's negative 2 cosine t. And an antiderivative of 3e to the t is 3e to the t. And we have an arbitrary constant. Don't forget the arbitrary constant. Now, problem 69. We're back to the other problems that we've just done a few minutes ago. F prime of t is 2t minus 3 sine t. And notice that this is a first derivative, only first derivative, not a second derivative. So there's only one condition. F of 0 is 5. So an antiderivative of 2t is t squared. An antiderivative of negative 3 sine t is 3 cosine t. Of course, we have an arbitrary constant. F of 0 is 5. Cosine of 0 is 1, so what we get is 5 is equal to 3 plus c, so c has to be 2. So f of t is t squared plus 3 cosine t plus 2.